In the previous lessons, we have learned sp3 hybridization and sp2 hybridization of carbon. In this lesson, we are going to learn hybridization in ethyne, that is sp hybridization of carbon. So let's begin. Hybridization of carbon in ethyne. Let us write molecular formula of ethyne. C2H2 ethyne. Structure formula is this: carbon-carbon triple bond, one hydrogen here, here one hydrogen. In this molecule, carbon atoms are sp hybridized. Let us see electronic configuration of carbon. At the excited state, in the outermost shell of carbon, s orbital contains one electron, 2px one electron, 2py one electron, and 2pz one electron. Here, carbon atoms are sp hybridized, that is, in the outermost shell, sp hybridization occurs. S and p hybridization occurs between s and p orbitals. Then two orbitals are formed. These orbitals are named sp orbital. This is sp orbital, and we see that two orbitals, p orbitals, remain unchanged. Those can be showed in this way: dumbbell shaped p orbital, which can be py, another dumbbell shaped orbital that remains unchanged, unhybridized, that is 2pz orbital. This is 2py orbital. Another one is 2pz orbital. This is orbital structure of carbon in which sp hybridization occurs. Here, let us see orbital structure of ethyne. Carbon, which is sp hybridized, sp orbital, two unhybridized orbitals, 2py, another one unhybridized orbital, which is 2pz. This carbon, hybrid orbital, another hybrid orbital, sp hybrid orbitals, and two orbitals remain unhybridized. This is 2py, this one is 2pz. With this carbon, one hydrogen atom. S orbital of hydrogen overlaps sp orbital of this carbon, and as a result, carbon hydrogen sigma bond is formed. With this carbon, one hydrogen atom. S orbital of hydrogen overlaps sp hybrid orbital of this carbon. As a result, here another carbon hydrogen sigma bond is formed, and we see that in between two carbon atoms there are triple bond. One bond is formed through overlap between sp and sp hybrid orbitals in this way. Sp hybrid orbital overlaps this sp hybrid orbital of this carbon. As a result, carbon-carbon sigma bond is formed. That can be, suppose middle bond is the carbon-carbon sigma bond, which is formed through overlap between sp hybrid orbitals. Then two bonds are left. One bond is formed by the overlap of 2py and 2py sidewise overlap. This is one pi bond which is formed unhybridized 2p orbital, unhybridized 2p orbital. When unhybridized 2p orbital overlaps unhybridized 2p orbital of this carbon, then one pi bond is formed. Again, we see that this carbon contains 2pz orbital which is unhybridized. This carbon as well contains 2pz orbital which is unhybridized. So another bond is formed through overlap between unhybridized 2pz and 2pz orbital. That is, here overlap occurs between unhybridized 2pz orbitals. As a result, another pi bond is formed. That is, in between two carbon atoms, three bonds. One is sigma bond, which is formed through overlap between sp-sp hybrid orbitals. Two pi bonds are formed through overlaps between 2py unhybridized orbitals and 2pz unhybridized orbitals. In this way, ethyne molecule is formed, in which two pi bonds and one sigma bond between two carbon atoms, and with one carbon atom, one sigma bond, with another carbon atom, another sigma bond. This is complete orbital structure of ethyne. Here, sigma bond is a kind of primary bond because initially sigma bond is formed. After forming sigma bond, pi bonds are formed. That is why pi bonds are called secondary bonds. So sigma bond is a kind of primary bond. Pi bonds are called secondary bonds. This is all about sp hybridization of carbon in ethyne. No more today. Thank you very much.